And we're live. Hi, I'm Phil McCaffrey, and this is 8:30 Prep. It's a production of 3-Hour Prep, my company. So if you want to do some tutoring with 3-Hour Prep, tune in every Monday night at 8:30. I unfortunately have a cold, and I apologize for that in advance. So I'm sucking on a cough drop, drinking some tea while we do some exponent problems. This is a continuation of last week where I posted some ACT and some SAT problems. So if my voice can hang with me, I'll do 14 exponent problems that are straight off of the ACT and the SAT. And the first one is in number 16. What you'll notice about the ACT problems is out of 60, there's somewhere around 20 to 25. There's always an exponent and root problem. So they love to put it in there. This is an easy problem to solve. They are all solvable, and this is one you could do very quickly. The first one says, which of the following expressions is equivalent to x to the 2/3? A fractional exponent is a root. So we write the 3 inside the root. The root symbol is called the radicand. And then we take and put the x squared in it. And look, that's answer K. We could also write it this way. The cube root of x, quantity squared. They mean the same thing. If you put in a number into your calculator and do it both ways, it'll turn out the same. The next one is a number 22. Notice how I said they hang around the 20s in the ACT. And this one says if a, b, and c are positive integers such that a raised to the b is equal to x and c raised to the b is equal to y, what is x times y? So I have to substitute a to the b, c to the b. The interesting thing about exponents is they can be distributed. So even though the bases are different, this is equal to a times c raised to the b. We'll try this out in a later exponent problem by putting in real numbers. But what we're going to try to do is tear through this while I still have some voice left. 25 from the ACT. The expression negative 8x cubed times the quantity 7x to the 6 minus 3x to the 5th is equivalent to, wait a second, we just saw that on the last one and the one before that. So its equivalency is what they're tracking. They're tracking if you know how to manipulate exponents. And we're distributing this x, negative 8x cubed, to 7x to the 6th. And when we multiply, we add exponents. So this becomes negative 56 x to the 3 plus 6. Let's stop right there and see if I have any negative 56 x to the 9th. Well, that one isn't, that one isn't, that one is. We have 2 more. So now all I have to look for is the next distribution, positive or negative, because it's the same number. And it's negative 8 times negative 3, and a negative times a negative is a positive. The answer choice is A. This is one of my favorite problems because it's so goofy. 3 to the x is equal to 54. Which of the following must be true? That is, what is the value of x? If you take algebra 2, you know that the natural log of 3 to the x is equal to the natural log of 54. Well, that's not really that important if you memorized what I told you last week, which is the powers of 3. 3 squared is 9. 3 cubed is 27. That's a 27. 3 to the 4th is 81. So 54 is between 27 and 81. X has to be between 3 and 4. If we finish this problem out, we would take x is equal to the natural log of 54 divided by the natural log of 3, which is about 3.6. That's the right answer, answer choice C. I'm not doing so bad on my voice. Let me take some tea with honey. Thanks for my wife for bringing some honey over. Once again, a number 22 off the ACT. This expression equals, or is equivalent to, 3 times a to the 4th over 3 times a to the 6th. 3 divided by 3 is 1. A to the 4 minus 6 is equal to a to the negative 2, or 1 over a squared, which is right here, k. Scientific notation. I include scientific notation in with exponents because they always use exponents. To do scientific notation, you count from the first digit over to where there's one digit left. So we go 1, 2, 3, 4, 5, 6, 7, 8. So this is 6.7 times 10 to the 8th plus 7.0 times 10 to the 8th. Well, 6 plus 7 gives me 13. I have to move the decimal place one more time, and from 8 to 9. 1.37 times 10 to the 9th. Answer choice D. These are in the description of the video, these PDFs. Another 25, notice they're right around 25. And this says 4.8 times 10 to the negative 7 divided by 1.6 times 10 to the negative 11th. Well, 4.8 divided by 1.6 is 48 divided by 16, which is 3, not 4.8 minus 1.6. So D and E is wrong. Use the answer choices to guide you. It is just as important to know the wrong answer choices as it is to know the right answer choices. And 10 to the negative 7th divided by 10 to the negative 11th gives me negative 7 minus negative 11. The answer has to be positive. There's only one positive answer, and that is 3 times 10 to the 4th. Lastly, off the latest ACT, fresh off the press. This is the December 2019 ACT, and look at this ugly root and exponent problem. It's a number 54. It's in the last 10. It's supposed to be really hard. But we said a root is a fraction. So I've got x to the 4 over 6 times x to the 4 over 3. When we multiply the same bases, we add the exponents. So 4 times 6 plus, let's double this, 8 times 6, so we have a common denominator, equals 12 over 6, or 2. The answer is x squared. Interesting thing about this is I always say pick the ugly answer in a hard problem, but this isn't an ugly answer, so that doesn't always work. If you were to guess, I wouldn't have guessed x squared, so that system doesn't work. And that's ACT exponents. Let's now switch over to SAT. The one thing that you'll notice the difference between the SAT and the ACT is the SAT always draws this big bar between the problems. So when we're doing SAT problems, you'll know they're off the SAT because of this big bar. Oh, look, the exact same problem. The SAT and the ACT are like a Venn diagram. Most of the problems are on both. So what do we have? A to the 4th, 5th root. So a to the 4 over 5 times a squared to the 3rd root is equal to some value of a to the n. What is the value of n? Same bases, multiplying the exponent. 4 to the 5th, 4 fifths plus 2 thirds. Learn how to add fractions quickly. This is on the non-calculator section. You multiply the denominators, the bases. And when you're multiplying, you multiply the denominators. So my denominator is 15. Let's stop right there. The answer has to be some factor of 15. 11 over 4 is wrong. 3 over 4 is wrong. Cross multiply. This gives me 12 plus 10 equals 22 over 15. Answer, 22 over 15. 8 over 15 is too small. Can't do this one on your calculator because it's a non-calculator section, and that's one of the reasons why I don't like the SAT. All right, a non-calculator, non-multiple choice grid-in question. If a raised to the b over 4 is equal to 16, for positive integers, a and b, what is one possible value of b? Well, positive integers is the SAT's favorite phrase. Integer is its favorite word. An integer is a whole number and its opposites. numbers without fractions and decimals. So a to the b over 4 equals 16. Well, we have to pick numbers for a and b. What is one possible value of b? Is there a number such that if b is equal to 4, a raised to the 1 is equal to 16? There is. 16. 16 raised to the 1 power is 16. So b can equal 4. The other possible values are 1, 2, 4, 8, and 16. I'll let you work those ones out. Look at this ugly, nasty fraction in exponents. X squared y cubed all to the 1/2. X squared y cubed all to the 1/3 is equal to x to the a over 3, y to the a over 2. What's the value of a? What do I have to do? Distribute the 1/2. Athena Marsh, hi. This is going to look at comments. I've got comments up live, so you can comment. Hi, honey. Thanks for watching. X distributed 2 over 2, y cubed over 2, multiplied by x squared over 3, y cubed over 3. Woo! Now I have to multiply, which means I'm adding this x to this x, this y to this y. 2 over 2 plus 2 over 3. Well, 2 over 2 is the same as 3 over 3 because it's 1. So this becomes 5 over 3. 3 over 2 plus 3 over 3. 3 over 3 is the same as 2 over 2, so this becomes 5 over 2. The answer choice is 5. C. If x is not equal to 0, which of the following, what is the value of 4 times 3x quantity squared over 2x quantity squared? Well, let's square this bad boy. 4 times 9x squared over 4 times x squared. Becomes pretty easy. Let's do the favorite thing the SAT likes, which is to divide a number by itself or cancel. 4 divided by 4 is 1. X squared divided by x squared is 1. The answer is 9. Which of the following is equal to 9 to the 3/4? This is the 4th root of 9 cubed. I'm going to leave this blank because I'm going to use Phil's rule number 4. Look at the answers. 9 cube root of 9, yeah. 4th root of 9, I'm going to put a 9 cubed in there. Yeah, that doesn't work. Square root of 3, where did the 3 come from? 3 times the square root of 3. Well, 3 squared is 9, so that means 9 to the 4th. That's 9 cubed. This is 3 to the 3 times 3 times 3 times 3 times 3 times 3 times 3. That, my friend, is 9 cubed. 3 sets of 3 squared. Since there are 4 of them, the 4th root of 3 multiplied by itself 4 times is 3. This comes outside. I'm now left with 3 to the 4th root of 3 times 3. The 4th root of 3 times 3 is also equal to 3 to the 2 over 4, or 3 to the 1/2, which equals the square root of 3. Move this back over here, and I get 3 root 3. That, my friends, is a very ugly, tricky SAT problem that I would practice over and over again. And I think, oh, one more. This is our last problem of the day. Does it check? Yep, that's the last one. Okay, this is an exponential function. It's the graph of a function. So here's the question. The graphs would be underneath it, but I put them on the side to make it a little bit bigger. The function of x is 2 to the x plus 1. If the function is defined above, what are the following is the graph of negative f of x? When they ask you to graph a function, take a look at the answers. What do we see? 1, 2, 3. 1, 2, 3. 1, 2, 3. They're only putting 1s, 2s, and 3s. So 1, 2, and 3 has to work. What else do they put on here? 0. So why don't I make a t-table? I'm going to put x, the function of x, and, because they're tricky, I'm going to put the opposite of the function of x. If x is equal to 0, 2 raised to the 0 power plus 1 is the function of x. 2 to the 0 is 1. 1 plus 1 is 2. If x is 0, the function of 0 is 2. So the function opposite, the opposite function, is negative 2. I'm looking for the number 0, comma, negative 2. 0, negative 2. 0, negative 2. We have a winner. 0, negative 2. 0, negative 2. All I had to do to solve this problem was put in 0 on a t-table and plot 0, negative 2. That's Worksheet Exponents M205 from the ACT and the SAT. I did 14 problems in 17 minutes. That's pretty good with no voice, and I'm going to quit there. Thanks so much for watching.